Venus, our celestial neighbour, is a planet shrouded in mystery and danger. Often referred to as Earth's twin due to its similar size and composition, Venus presents a stark contrast in terms of its environment. It stands out as the hottest planet in our solar system, a fact that seems counterintuitive at first. Despite being the second planet from the Sun, Venus experiences temperatures that far exceed those of Mercury, the closest planet to our star. After all, Venus is farther from the Sun than Mercury. One would naturally assume that the closer a planet is to the Sun, the hotter it would be. This is true to an extent, but Venus defies this simple logic. Mercury being closer should be hotter, right? Its proximity to the Sun means it receives more direct solar radiation. However, the reality is more complex. However, Venus defies this logic, boasting surface temperatures that can reach a staggering 465 degrees Celsius, or 869 degrees Fahrenheit. This makes Venus the hottest planet in our solar system by a significant margin. This intense heat is enough to melt lead and is a testament to the powerful forces at play on this seemingly inhospitable world. The surface of Venus is a hellish landscape, dominated by volcanic plains and deformed mountains. The reason for Venus's extreme heat lies not in its distance from the Sun, but in the composition of its atmosphere. Venus's atmosphere is composed mainly of carbon dioxide with clouds of sulfuric acid, creating a thick, oppressive blanket that traps heat. Venus is a prime example of what scientists call a runaway greenhouse effect, where the planet's atmosphere traps heat so effectively that it leads to ever-increasing temperatures. This phenomenon has had devastating consequences for the planet's climate. The surface pressure on Venus is 90 times that of Earth, equivalent to being about a kilometre underwater in Earth's oceans. This runaway greenhouse effect has transformed Venus from a potentially habitable world billions of years ago into the scorching inferno we see today. Understanding Venus's climate helps scientists learn more about the potential future of Earth's own climate. To understand the searing heat of Venus, we need to delve into the science behind the greenhouse effect. Imagine the Earth's atmosphere as a giant blanket wrapped around the planet. This blanket is made up of various gases, some of which act like tiny heat traps. These gases, known as greenhouse gases, allow sunlight to pass through and reach the Earth's surface. As the Earth's surface absorbs sunlight, it warms up and radiates heat back into space. However, greenhouse gases in the atmosphere capture some of this outgoing heat, preventing it from escaping back into the vastness of space. This trapped heat warms the planet, making Earth habitable for life as we know it. On Earth, the greenhouse effect is a natural and essential process for maintaining a life-supporting temperature. However, on Venus, this effect has gone into overdrive, creating a scorching hellscape. The key difference lies in the concentration of greenhouse gases, particularly carbon dioxide, or CO2, in the two planets' atmospheres. Earth's atmosphere contains a relatively small percentage of CO2, about 0.04%, while Venus's atmosphere is a choking 96.5% CO2. This incredibly dense blanket of CO2 traps an enormous amount of heat, leading to the planet's extreme temperatures. It's like comparing a thin sheet to a thick, heavy quilt in terms of their heat-trapping capabilities. The extreme greenhouse effect on Venus is a stark reminder of the delicate balance that governs planetary climates. This balance is crucial for maintaining conditions that can support life. And Venus serves as a cautionary tale of what can happen when this balance is disrupted. Scientists believe that Venus may have once had a more Earth-like climate billions of years ago, with liquid water oceans and a more temperate atmosphere. These conditions could have potentially supported life, making Venus a twin to Earth in its early history. However, a runaway greenhouse effect transformed Venus into the inhospitable world we know today. The planet's surface became a scorching wasteland with temperatures hot enough to melt lead. As the Sun's energy output increased over billions of years, temperatures on Venus began to rise. The intense solar radiation played a significant role in altering the planet's climate. This increased heat caused any liquid water on the surface to evaporate, releasing water vapor into the atmosphere. The loss of water bodies marked a turning point in Venus's climatic history. Water vapor itself is a potent greenhouse gas, further enhancing the warming effect. This created a thick, oppressive atmosphere that trapped even more heat. This led to a vicious cycle of increasing temperatures, more evaporation, and a thickening atmosphere. The once potentially habitable planet became a cautionary example of climate change gone awry, illustrating the delicate interplay between solar energy and atmospheric composition. A carbon dioxide blanket, Venus's thick atmosphere. The runaway greenhouse effect on Venus was further exacerbated by the planet's inability to regulate its carbon dioxide levels. On Earth, carbon dioxide is naturally absorbed by oceans, plants and rocks, preventing it from accumulating to dangerous levels. However, Venus lacks these natural mechanisms for carbon dioxide removal. As temperatures soared on Venus, any oceans that may have existed would have boiled away. Without oceans or significant plant life, there was no way for Venus to absorb the excess carbon dioxide building up in its atmosphere. This led to a thick, suffocating blanket of carbon dioxide that trapped heat with relentless efficiency, driving temperatures ever higher. Sulfuric acid clouds, reflecting heat and trapping it. Adding to Venus's woes are its thick clouds of sulfuric acid. These clouds, while reflecting some sunlight back into space, also contribute to the greenhouse effect. The sulfuric acid droplets in the clouds are highly reflective, bouncing back a significant portion of incoming solar radiation. While this reflectivity might seem like it would cool the planet, the reality is more complex. The sulfuric acid clouds, while reflecting some sunlight, also trap heat very effectively. They act like a lid on a boiling pot, preventing heat from escaping while still allowing energy to enter the system. Lessons from Venus, a cautionary tale for Earth. The fate of Venus serves as a stark warning to us here on Earth. Once a planet with conditions possibly similar to our own, Venus now endures a runaway greenhouse effect, making it inhospitable. While our planet is different from Venus in many ways, the underlying principles of the greenhouse effect are the same. The greenhouse gases trap heat in the atmosphere, leading to a rise in global temperatures. The rapid increase in carbon dioxide levels in Earth's atmosphere due to human activities is a cause for concern. Industrial activities, deforestation, and the burning of fossil fuels are major contributors to this rise. While Earth has natural mechanisms for regulating carbon dioxide, such as forests and oceans that absorb CO2, these mechanisms have limits. They can only absorb so much before becoming saturated. If we continue to emit greenhouse gases at our current rate, we risk pushing the Earth's climate system towards a tipping point. This tipping point could lead to irreversible changes in our climate. The consequences of such a scenario could be catastrophic, leading to rising sea levels, more extreme weather events, and significant disruptions to ecosystems and human societies. We must act now to reduce emissions and protect our planet for future generations. Unlocking Venus's secrets, missions, and discoveries. To better understand the risks of a runaway greenhouse effect and its implications for Earth's future, scientists are actively studying Venus. Space missions, such as NASA's Magellan spacecraft and the European Space Agency's Venus Express, have provided valuable data about Venus's atmosphere, surface, and evolution. These missions have revealed the intricate workings of Venus's atmosphere, the dynamics of its sulfuric acid clouds, and the long-term effects of a runaway greenhouse effect. The data collected from these missions are crucial for refining climate models and improving our understanding of planetary atmospheres. Our future, mirrored in Venus. Venus, the scorching enigma, stands as a testament to the delicate balance of planetary climates. Its runaway greenhouse effect serves as a stark warning to us here on Earth. The lessons we learn from studying Venus can guide us in making informed decisions about our own planet's future. By understanding the factors that led to Venus's extreme climate, we can work towards mitigating the risks of a similar fate for our own world. The future of Earth may very well depend on our ability to learn from the fiery fate of our celestial neighbour. Join us on our journey. Like if you enjoyed the video, and subscribe to learn more about science you need to know.